Welcome, everybody, to this re-recording of this morning's masterclass due to technical issues. My name is Jonas Peterson, and I am the head of the UK operations for the Media Press Group, the largest media metadata provider for the European continent. And today we want to take you on a very quick and intense 30-minute masterclass journey. And we're going to be talking about how to add value with AI in media metadata. To give you a quick background, at Media Press, we have been working with AI for a decade. We started in computer vision because we deal with vast amounts of images. I think it's roughly 50,000 a week at the moment. And different AI services have been used there for a long time. But the focus today will be on natural language processing, which was arguably the hottest topic last year, not just in our company, but probably in quite a few other companies. I would claim nearly all of the companies in the media space in the last year. It was definitely high up on the agenda. And joining me today is Aleksander Obuchowski, who is the head of AI at Media Press Group. And he has been instrumental to implementing large language models for metadata enrichment at our group. I want to super quickly introduce him as a person and speaker. He has been working in academia before, published more than 10 papers, some of them really impactful. This earned him a spot on the Forbes 25 under 25 list for impact in natural language processing, actually. And he has been teaching at the Polish-Japanese Institute for Information Technology. He also published a book on prompt engineering and is going to give you the keynote today. Briefly about the Media Press background, here you just see a few excerpts and numbers about the company that show the sheer size of data, channels, broadcasts, households that we interact with on a daily basis, which is just another indicator that AI at Media Press is a very important additional tool, but how we use it in detail, Oleg is going to tell you now. Oleg, over to you for a 20-minute intense and educational keynote for our viewers.
Thank you, Jonas. So to truly understand the story that we want to present here, first we have to discuss about our values here at Media Press, especially regarding to AI. Firstly, we want to be responsible about implementing our solutions. So we just don't want to follow trends without thinking about them. We don't want to follow the hype. We don't want to implement a solution that could harmfully impact both our employees and our clients. We want to focus on the quality of our service. So it's not only about automation, it's also about preserving and increasing the quality. And thirdly, about efficiency. So we want to develop solutions that are efficient, that are easily scalable, and once developed can be implemented for millions of texts, because as Jonas shows you, we are dealing with large volumes of data. So coming to the problem that we want to discuss today. Firstly, let's talk about the data that we are processing, about movie synopsis. This is one of the types of metadata that we process here at Media Press. For each movie, broadcast, show, or interview, you have this synopsis that is essentially description of the content. And those descriptions can be longer, they can be medium length, or they can be short. It all depends on how much space our clients have in their tools that they want to use our metadata in. If you are talking about streaming services, you have couples of lines. For example, in the newspapers, you have a full page dedicated to some content. And for TV, you only get one line or something like that. And we have to support all those different formats. There's 4 basic formats that we support: long, medium, short, and very short. But those formats also vary in length, and different clients are requesting different length of the synopsis. We also deal with multiple languages: Polish, English, German, French. All those different languages has their dedicated metadata and therefore dedicated synopsis. So we not only have to support different formats, but also different languages. So as you can imagine, it is very difficult to produce this kind of data, especially at the scale that we operated with. So we decided that we want to explore the help of AI, especially large language models, in streamlining this task. So here is the initial overview of our system, where we wanted to take the long description that contains all the necessary information and a lot of content, or maybe even a few samples of those long description per content, because one content can also have multiple long descriptions. And then we decided to use AI model to, based on the long descriptions, create short descriptions and medium descriptions. Obviously, those descriptions then would be presented to our editors just as a form of suggestion, because just to emphasize this, from the beginning, we wanted this to be an assisted editorial process, not replacing human editors, but assisting them, making their job quicker, easier, and also safer with the suggestions. And only after the AI system and humans work together would this data come to the MediaPress database. But what you might have seen if you tried using ChatGPT or similar solutions, it's not often that simple because the quality can vary. It takes quite a lot of prompt engineering and tinkering with this model to produce high quality results. So the initial experiment, based on the initial experiments, the medium and short text didn't have enough quality for us to meet our standards. So basing on this simple proof of concept, we then developed more robust solution, more expanded the system. So how the system works right now? So the first part of the system is prompt engineering. So we have this elaborated prompt that is right now probably a couple of hundreds or maybe even up to 1,000 words long. When we describe the content in detail, we use different prompt engineering techniques such as chain of thought, such as think step by step, or maybe even few-shot prompting when we ingest dynamically a few examples. So the prompt itself is a huge part of the system. Then the system is also, besides the prompt, fed a few examples of the source text, so the longer texts, as I said, multiple text per content, depending on how much we have. And we also use different other metadata, such as title of the content that we want to describe, desired length. So for example, it's not only short, medium, or long. You can specify the exact number of characters that you want. And also genre is the part of the input to the system. So we want the system to focus on different parts of the content, not only the description, but other metadata that we have. Those things as a whole, I fed to large language model, and then LLM produces candidate text. And also it doesn't produce a single text for the desired length, but multiple candidate text, just to have a pool of text to choose from. Then we have our scoring system that is able to evaluate those candidate text based on the correctness, based on the engaging of the description, based on the language. And if some candidate text doesn't fit the standard, it is fed back to the LLM with sort of a feedback that this, and this is wrong. And our system corrects it and produces new candidate text. Then if a candidate text passes the internal scoring system, the first scoring system, we also have some handcrafted rules, safety checks, to make sure the content is of the highest quality. So we check the stuff as if the title appears in the description because it shouldn't. We check for grammatical errors. We check for specific blacklisted words, etc. And then after this rule-based evaluation system, only then it goes back to the editors and is presented as a candidate to the editor, and then editor can choose from it. And only doing this large system with this internal feedback loop and all this prompt engineering and handcrafting rules, only then the system was able to produce high quality results to truly benefit the editors. We have also what we call external feedback loop. So the system itself, when we update the system, when we fine-tune the prompt, when we change the rules, when we, for example, do new language, or change anything in the system, we don't just put the new version to production because we are happy about the few samples. We present it to the editors as a form of blind test or A/B test, when the editors are presented in one column with the synopsis from old solution and in different columns synopsis from the new solution. And they can compare those. They don't know which is which, so it is a blind test. They just say which one they like better. And if the new version of the system is performing better, then we can accept this version and try to work on an even newer one, because it is a constant feedback process, feedback loop. This is because even if we don't tinker with the system in any way, don't change it, because the large language models are often updated and are changing, it is necessary to monitor the system constantly, continuously, let's say. So even if we don't change anything, once a month or so, we are doing this blind test to make sure the content, the quality of the content isn't reduced. And coming to the scalability, because one issue that we also encountered in our initial solution is that the large language models are slow. It takes from a couple of seconds to even dozen of seconds to process a single text. And it wasn't simply acceptable at our scale to process hundreds of thousands of texts. So what we decided to do, we have our Kubernetes cluster, and we design each instance of the app to asynchronously communicate with the large language model server, so we can have multiple instances of the same app, and each of those instances can also asynchronously communicate with different LLMs. So we are able to scale this solution pretty much indefinitely, because we can replicate the same instance many, many times and produce those texts in parallel. So maybe one text takes a couple of seconds, but then hundreds of texts also takes a couple of seconds, because we have this parallelism. And that's how we solve the issue of the speed of execution of the system. And it is a quite good architecture, because we can dynamically spin up the system and process thousands of texts. So for example, if you come to us and say, I need 100 of short text for next week, technically we can probably do that. And speaking about results, because, okay, let's talk about numbers. So the number of text we processed is more than 500,000 in the previous 4 months, when the system was fully operational and running online. We observed improved quality in the editor work, because editors are working together with AI. As I said, they have those candidate text, and they can use this as suggestions and focus their time also more on fine-tuning the small details. So they don't have to write the synopsis from scratch, but they already have the template, and they can spend their time better on just fine-tuning the small details, correcting small mistakes, and the overall quality of the synopsis is increased. And talking about numbers again, when we evaluated, we did some monitoring in the system and check how many of those synopses are modified. It appeared that 1/3 of the synopses that are returned as suggestions are accepted without modification. So the editors read them and decide they are high quality enough to be used. It may not seem like a lot, but again, look at the scale. If we talk about 500,000 of text, 1/3 of that is quite a lot of automation. Then the rest, when we talk about the rest, about 2/3 of overall text were used with varied modifications, so minor to large. We decide this based on how much characters or how much words are changed between the initial proposition and the end results. And you can see that overall only 20% of the text weren't used at all. We were able to speed up the process for 2/3 of the text. And that's how, in the end, we solved this problem with these 3 values in mind. So we develop a solution that is responsible, because we have those feedback loops, we have those guardrails, we have this handcrafted evaluation and automatic evaluation system, and the system works together with a human to produce the best result. We solved the issue of quality because, as I said, again, the overall quality of the text improved because editors had more time to fine-tune a single text. And we solved the issue of efficiency because in the end, the system is automatically scalable and is able to process thousands of texts at a time. Thank you, and back to you, Jonas.
Thanks, Oleg. Thanks for the presentation. I want to circle back to a few interesting follow-up questions that we received this morning to have them recorded here as well. But before that, yeah, sure, let's jump here. A very brief and gentle self-promotion. I want to just tell the viewers about a new venture that MediaPress has been starting last year. It's called K2 AI, and it's a subsidiary of the MediaPress group that is born out of the AI team at MediaPress. And the reason why we have taken this step to found K2 AI is that we have, in conversation with various clients over the last year, but actually earlier as well, heard that issues that we solve internally, and this is natural language processing, what Oleg has been talking about, but it extends further to computer vision, business intelligence, or general AI strategy and consulting. Those issues are issues that are shared by our clients, and we want to be able to serve them and carry knowledge and services that we have in-house to you as well. If this is something ranging from strategy, implementation to operation that's currently on your agenda as well, and you feel like you could benefit from outside help, then a K2 AI is a potential option that you have. There's a QR code. I'm going to share a link as well to just a non-committing free consultation with one or two experts from K2 that would simply be in a conversation with you and gauge whether there is benefit for you to be gained, and it's a match. K2 can help you at essentially whichever of the described stages with AI you're currently at. If you just leave your contact details, if you're interested, we're going to give you a call, schedule the discovery, a meeting, and see whether there can be mutual value generated. I want to now come to a quick Q&A session that we had this morning, which looking at the time, yeah, I think we can add one or two of those because they might be interesting to viewers catching up as well. The first question, Oleg, I want to pose to you again, was about the type of LLM models used. Is it only GPT-4 that we compare? How far did MediaPress go when implementing LLMs into reviewing and making the final decision as to which of the foundation models out there to actually take?
Okay, so it's actually an interesting question because it all comes to down to the type of data that we have and the fact that this data is multilingual. So if we were only talking about English data, English synopsis, we could use different large language models, even open source ones like Mixtral. They're on par with, let's say, GPT 3.5. But when we have experimented with our German, our French data, with those open source models, there was a huge gap between GPT-4 and those alternative models. So if you want to develop your solution fully in English, it's probably good to explore alternatives, and there might be some even better for your use case. But when you talk about multilingual content, unfortunately, there currently is no alternative, and believe me, we have tried, we have searched for it, but nothing can match the quality of GPT-4 in multilingual data.
Status quo, but very important to know this observation. Another question that I'd also like to feedback is just digging a bit deeper into the prompt engineering you mentioned. How much effort did MediaPress invest, and what was the strategy going about it? What were the difficulties and potential unsolved problems encountered?
Okay, so the prompt engineering part is tricky because most of people, when they think about ChatGPT, they think about their personal use and that they can just in one line define the task and ChatGPT will solve it for them and everything will be fine. But when we talk about business and operating at scale and ensuring quality from business perspective, it's not that simple. So we have spent a lot of time on prompt engineering, even I would say 2 months of different iterations, and we did it methodologically. So we, as I said about this feedback loop, so we tested different prompts, observed the results, tested alternative prompts, etc. When we talk about the prompt engineering techniques, I briefly mentioned a few. So, for example, few-shot prompting, when you dynamically input relevant input-output pairs as examples to the model. Chain of thought, where the complex task is split up into simple series of simple tasks, and the model is thinking step by step. Also, self-reflection is a part of this feedback loop that I said, when the model is asked to judge its own quality and score the candidate text and feed them back if something goes wrong. There's self-reflection and stuff like that. Yeah. So overall, I would say quite a lot of time in the prompt engineering, quite a lot of different techniques that we used.
But very much like a good ROI or time well spent, because you do see the results in quality coming out on the other end.
Yeah, definitely. Because without this, we probably, as I said, we wouldn't implement the system if it wasn't on the highest quality. So to put it in production, we had to spend this time on prompt engineering, but it was good ROI, because in the end, we are able to process hundreds of thousands of text, not just theoretically, but actually we did it. And we sped up the process very, very much. So there are huge cost savings and also quality improvement for our clients. So it was worth to spend those, let's say, 2 months reiterating over and over with different techniques.
I want to ask one final question before we wrap it up about tonal recognition. There was a question this morning. The example, I believe, was something along the lines, if you get different synopses, one might be a sentient analysis, I think we're talking here, because it comes from the psychological thriller versus from the comedy aspect, or different. How far is MediaPress in using AI for classification and sentient analysis?
So you mentioned two things. So let's start with the first one. When we talk about putting different the tonality, so we accept genre as a part of the input, and it's a part of the prompt that the model is guided to focus on the genre. So it says that it's a, for example, romantic comedy or thriller or documentary, and is asked to, act accordingly and adjust the language to fit it best the description. So it is actually one of the most important things that we take into account. And also the scoring system takes a look at it when it does the scoring. So we check if the description fits the genre. When it comes to different things like sentiment analysis, it's not really necessary in this case, because maybe not necessary, but it's implied, because the system is also asked to follow specific guidelines when it comes to the tone of the speech or the writing, and the system is then those things are evaluated, but there is no like explicit, let's say, sentiment analysis. It's all a part of this larger prompt that is text-to-text interface of large language model.
Right, got you. Indirectly flows into the evaluation, yet at least for this use case, not specifically required on its own. Oleg, thank you very much. We stayed below the 30 minutes for the re-recording. I hope it was useful to everybody watching this afterwards. Thanks again, everybody. Have a great day. Thanks for tuning in.
Thank you.